when we are talking about geostatistics, we have to talk about statistics. And when we are talking about statistics, we have to talk about random variable. Random variable is the variable that takes its value, forming a set of elementary elements randomly, according to certain probabilistic mechanism. For example, we can die a roll, like the plain boxes, and look what kind of values we're gonna take. If we drop two boxes, our values can be somewhere between 2 and 12. But we're gonna have different probabilities of getting different values. For example, we get only a small probability of getting 2 because it's only a single combination that give us this value. Only if both boxes gonna show us 1, we're gonna obtain the sum of 2. But if we're gonna drop the boxes to get 7, we get much more probability because we get a lot of combination: 1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, 4 and 3. So there are a lot of possibility to get these values. The total amount of combinations is 36. That means we can count the probability of getting a certain value. That simply means that even a random variable is not completely random, but it follows a certain probabilistic rule. Random variables can be of two different types. It can be discrete or discontinuous. In this case, it is separately taken values. For example, in case of geology, we can talk about facies. It can be shale, it can be sandstone, it can be limestone. It cannot be like sandy limestone. We can set on a certain separate values. Another type is continuous random variable. In this case, it can take all numerical values from some finite or infinite interval. For example, porosity. It can take any value between 0 and 1. So you can have porosity of 0.15 or 0.14, and it doesn't matter. We can get any type of the value. For the discrete variables, a random variable can take a certain values with a certain probability. If we go back to our example on the plain boxes, we can count its probability. The probability of getting 2 gonna be equal to the amount of combinations of getting 2 divided on the total amount of combinations. For continuous variables, it works a bit differently. We cannot take a separate value, but we have to take a certain interval in which we're going to obtain these values. For example, let's have a geological example. We got 10 wells in the field. In 2 wells, our porosity is less than 10%, and in 8 wells, we get porosity more than 10%. That means that if we drill the new well, the probability of getting value less than 10% porosity is equal to 0.2. So we got much more probability of getting low values than the probability of getting high values. But in practice, the probability distribution of the random variable, porosity in our case, is judged only by the tests. Repeating the test, each time we register a different value of this random variable. So we have to talk about the relative frequency, or simply frequency, of a random event. That means that we are not quite sure about the random variable, about the porosity in each new well. We can only assess its probability. And the more values you have, the more stable your statistics is. For example, if on your field you got 10 wells and you drill the new well, and in this new well you obtain porosity less than 10%. That means now you change your statistics. It was 0.2 by 0.8, but it became 0.3 to 0.7. You see? You drill the new well and the total statistics of your field has changed, and it changed a lot. But in case if you have 100 wells and you drill the new one, this new well will not gonna change dramatically your total statistics. That means the more wells you have, the less the influence of each new one. The dependence on the frequencies on the intervals determines the empirical probability, and it can be shown as the histogram. On the y-axis, on the histogram, we get the relative frequency of a certain value. On the x-axis, we get the certain value of variable. For example, if we take the histogram of the porosity distribution, we can find out that we got only a few wells with a porosity, let's say, less than 10. We got a lot of wells with a porosity between 10 and 15, and we got a few wells with a porosity more than 15. That histogram shows us the distribution of our function. Once we talk about the random variable, we have to talk about a certain values that we can calculate. The first one is the average value. The average value is the amount of the equal to the sum of average values of our variable. So we simply take a lot of realizations and find its average. In addition to that, we can count the variance. The variance shows us the how much our certain random variable is different from its average, from its mathematical expectation. Let's show it on an example. Imagine that we got two fields with the 10 wells drilled with the different porosities. In case of the field A, our average value is 15. And in case of the field B, we get average value of 15 as well. But our variance in the first case is 4.6, while in the second case it's 28.2. But what does it mean? Let's look at the example. For example, if we're gonna go to a certain oil field and we're gonna drill 10 wells and measure porosity in each well. And then I'm gonna ask you to predict what's gonna be the porosity in the new well drilled somewhere in the field. If you get your task to get the minimal possible mistake, you would say average. Just because the maximum mistake, in case if you take average, gonna be the distance between average and the maximum and average and the minimum. If you'll try to guess and choose any other values, your possible mistake gonna be higher. But what does it mean? Big mistake or small mistake? That is controlled by the variance. The higher the variance, the more the possible mistake of your calculations.